Augmented matrices. An augmented matrix is one based on a system of equations. For these examples, I'm going to be doing a system of 3 equations for all of them, but it is easily extendable to any number of equations, system of 2, 4, whatever. So an augmented matrix is simply a matrix of the numbers, generally the coefficients, if you would, and the number on the other side of the equal sign of the matrix. Very simple to see. So the first row of my matrix would be the coefficients of the x, the y, and the z. And then I usually put a dotted line. It doesn't have to be there, but I like to put it there. That's going to represent my equal sign. And then I put the number to the right of the equal sign to the right of my dotted line. My second row would have the coefficients -1 for the x, 1 for the y, 5 for the z, and then on the other side of my dotted line I would put the number that it equals. The final row, the coefficients will be 1 for the x, 6 for the y, -2 for the z, and then 11 on the other side of my dashed line. That is an augmented matrix. Let's do another example. Let's say we have the system of equations 5x plus 2y plus 3z equals 6, 2x plus y plus 2z equals -1, and 3x plus 4y minus 7z equals 13. Can you write the augmented matrix that corresponds with this system of equations? I'm going to do this one quickly because I think you understand it. I would have 5, 2, 3, and then I like to put the dashed line for my equal sign, and then 6. Second row, I would have 2, 1, 2, -1. And the final row would be 3, 4, -7, 13. Very simple. Let's work it backwards. What if we had the augmented matrix 2, 5, 0, 8, 6, 1, -1, 3, -2, -4, 5, -11? Could you write the original system of equations that corresponds, assuming we're using x's, y's, and z's? Well, let's do it. These are the coefficients of the numbers, so I would have 2x's plus 5y's plus 0z's, so I don't really need to write it, equals 8. Then I would have 6x plus 1y minus 1z equals 3. And then -2x minus 4y plus 5z equals -11. Just like that. Now, why would I want to go backwards? We're going to see why in the next video, but I'll lead you a little bit. What if I had this matrix? Or again, I'm going to do x, y, z's. Could you go backwards and write the augmented matrix, that is, turn it into a system of equations? Hopefully you see it's really easy. That is, the original equations are very simple. In fact, I get 1x plus no y's plus no z's equals 2. I get no x's plus 1y plus no z's equals -4. And finally, no x's plus no y's plus 1z equals 3. So what we're going to see in the next video is that we want to turn a system of equations into an augmented matrix and then reduce it down to something, maybe not all the way, but something simpler that allows us to solve.